So today we're going to look at polynomial functions, take a look at some of their zeros, how we can find them, what it means, all that good stuff. So very first thing we're going to do is kind of jump back to maybe 4th or 5th grade math. And we're going to do long division without a calculator to just try and remember how would we do this. Remember the process, remember the algorithm. So if we're trying to divide 3,587 by 32, first thing you would do is put the 32 on the outside. You'd make a little house, and you'd have 3,587 on the inside. And then we would start and say, okay, take the first number, and can 32 go into 3? And it can't. So then we'd have to take the next one and say, can 32 divide evenly into 35? And it can. It can go in one time. So we put a 1 above the 5. Take 1. And now we multiply by that 32. So 1 times 32 gives us 32. We subtract, which we get 3 left over. And then we'd bring down the 8 and we try that process again. And say, does 32 go into 38? And since it does, it goes in once evenly. So I put a 1 up there and I say 1 times 32 is going to give us 32. I'm going to carry this work over here and subtract out the 32, and now I'm left with 6. So I'd want to bring the 7 down and do the same process and say, okay, does 32 go into 67? And it does twice. So 2 times 32 would give us 64. And when we subtract, we have 3 left over. So we could say there we would have a remainder of 3. And sometimes you would do like a little R3 over here. It all depended on how you wrote that out. So that's that process of long division. Okay, with that in mind, now we're going to do the same thing, but we're going to do it with variables. So you're going to notice all these coefficients are pretty much the same numbers that we had up above. It's just this time we have some variables attached to it. So I have 3x plus 2. It's going to go on the outside. And on the inside, we have 3x cubed plus 5x squared plus 8x plus 7. So we're going to start the process maybe a little differently. And we are going to take the first term on the outside and the first term on the inside. And we're going to say, okay, 3x times what will get me 3x cubed? And, well, that should give us 1x squared. So now, just like we would before, we would take that top number, multiply it by the outside. It's just this time I have 2 numbers to multiply it by. So I have x squared times 3x. So there's 3x cubed. Now go back and do it for the 2. X squared times 2. So now we have plus 2x squared. And just like we would in division up above, I'm subtracting. Just keep in mind you're subtracting everything. Okay, so 3x cubed minus 3x cubed, that's 0. That should always happen. That first term should always drop out. Go to the second term. 5x squared minus 2x squared will leave us with 3x squared. And now just like we did before, we're going to bring all of these terms down. That's a little different. We would only bring maybe one number down. I'm going to say let's bring them all down. And then we start the process again. So you take the first term, that 3x, and say 3x times what gets me 3x squared. So this time 3x times x will get you 3x squared. And now we're going to do the same thing, multiply through. So x times 3x is 3x squared. X times 2 is 2x. And again, like we did, I want to subtract everything. So the first term, we can see 3x squared minus 3x squared drops out. Again, that should always happen. 8x minus 2x, we have 6x. And now again, I still have that 7, so we're going to bring that down and try this process one more time. So again, we look at the first terms. Okay, so 3x times what gets me 6x? Well, 3x times 2. Okay, so multiply by everything. 2 times 3x, there's our 6x. 2 times 2, there's 4. And I'm going to subtract. Again, that first term drops out. 7 minus 4, we're left with 3. So again, we have that remainder. Now, a couple of things that we want to be aware of. These have different terms. So at times we'll be referring to these in different terms. For instance, we know that this is the remainder. That's no problem, right? Okay. The number on the outside, what we are dividing by, that is your divisor. The number under the house, that is your dividend. And what we get on the top of the house, that's your answer or your quotient. Okay, so we have two ways that we can express your answer. Your answer can be expressed in what's either called polynomial form or fractional form. If we were to do polynomial form, we are going to take our divisor and we're going to multiply it by our quotient, and then to that we're going to add on the remainder. So if we look up above, our divisor was 3x plus 2. The quotient was x squared plus x plus 2. Sorry, my board is kind of dead there. And then to that, we're going to add on the remainder. So that's taking your answer and expressing it in polynomial form. If we express it in fractional form, now it's going to look a little different. So you're going to have your quotient. But to that, now we have to make a fraction. Well, your fraction's made by taking your remainder and dividing it by the divisor. Okay, so our quotient we have is x squared plus x plus 2. To that we add on the remainder divided by our divisor. Okay, so let's try another problem here. So we're going to divide f of x by d of x, and we're going to write it in both polynomial and fractional forms. So our d of x is going on the outside. Our f of x goes on the inside, and we start that process. Remember the process. Take a look at your first terms, and we're going to say x times what gets us x squared. We know that that's x. We have to multiply through on everything. So x times x, we get x squared. X times negative 1, we have a negative x. And now we're going to subtract. Okay, first term drops, that's good. Negative 2x, keep in mind minus a negative x, so that's plus a positive x, leaves us with negative x. Now let's bring down your other term. So we do this again. X times what gets me negative x. So x times negative 1 would get me negative x. Now we multiply through. So negative 1 times x, negative x. Negative 1 times negative 1, we get a positive 1. Remember, subtract everything. First term drops, that's good. 3 minus 1, 2. Okay, so if we're going to write this in polynomial form, we are going to take our divisor. We're going to multiply that by the quotient. That's the stuff on top. And we're going to add to that a remainder, which is 2. Okay, if we were to write this in fractional form, we are going to take our quotient, our answer, the stuff on top, x minus 1, and to that we add on our remainder divided by the divisor. So two different ways to express your answer. Now with this long division, we get a couple of theorems. The remainder theorem. So this is a nice quick way to test and see, do you have a remainder? So we want to see our factor. It says x minus k. If it's divided by x minus k, then the remainder is the function evaluated at k. So we have to know what k is. So I always think to myself, take that factor, think about it as like setting it equal to 0 and solving. So how do you find k? Well, solve for k, or solve for x, I'm sorry, and you'll find your k value. So for instance, over here, if I took x minus 2 and I set that equal to 0, and I solve, well, I find x equals 2. So what does that mean? That means 2 is your k value. So rather than saying f of k, we're going to say f of 2. Evaluate your function at 2. That's your k value. Okay? So anywhere I see an x, we plug in a 2. And we are going to simplify. So if we simplify this, so 2 squared is 4. 4 times 3, we're going to have 12. This is 14 minus 20. So that means our function at 2, evaluated at 2, is 6. So now we have to think, what does this mean? Well, this 6, this is saying this is the remainder. We have a remainder of 6 if we were to divide our function f of x by x minus 2. Okay, let's try the next one. So we have x plus 4. Same idea. We're going to start by taking our factor, that x plus 4. Let's set this equal to 0 and solve. So if we solve, we're going to find x is equal to negative 4. That's giving us our k value that we would plug in. So we evaluate your function this time at negative 4. So I'm going to go through, anywhere I see an x, I make it a negative 4. And then we're going to simplify. Okay, so negative 4 squared, we get 16. Times 3, we get 48. 7 times negative 4, we have a negative 28, and subtract out 20. So this time I'm looking at your function saying, okay, the function evaluated at negative 4 gives us 0. So that's kind of interesting. So I have to think, well, if it's 0, I have no remainder. That means x plus 4 has divided in evenly into the function. So this is actually saying, by having a remainder of 0, x plus 4 is a factor of f of x, meaning it divides in evenly. There are no remainders. So that's a great test to see if it's a factor, so that gives us our factor theorem, which is basically the same thing as the remainder theorem, but it's saying if you get a 0, then you know it's a factor and it divides in evenly. So this example that we have is the same exact example that we just did by trying that remainder theorem. So we already know it's a factor. So I could prove to you another way that it's a factor. If we tried doing this by doing long division, I should also see that I have no remainder. So start by saying, okay, x times what gets me 3x squared? That's going to get me 3x. And if I multiply through, so there's 3x squared, 3x times 4 is plus 12x. And we want to subtract everything. So our first term drops. 7 minus 12 is going to get us a negative 5x. We bring down the 20 and do it again. So x times what gets me negative 5x? So we have a negative 5. If we multiply through, so this gets me a negative 5x. Negative 5 times 4 is a negative 20. And when we subtract, we get no remainder. Okay, so think about what that means. If I were to write this answer in polynomial form, which is saying take my divisor, multiply it by the quotient. Look at what you just did. You just factored that function, that f of x. So by dividing that and either trying the factor theorem, the remainder theorem, and finding you have 0 remainder, or doing long division, here's a different way to factor a quadratic function. Okay, so we're going to try down here. It says use the factor theorem to determine whether x minus 2 is a factor. Okay, so we're going to start just like we did with the remainder theorem. Take that x minus 2, set it equal to 0, and solve for x. So we now know x is 2. That's going to be that k value that you plug in. Okay, so if I have f of 2, so this gets me 2 times 2 squared minus 3 times 2 plus 1. Okay, so if we simplify, 2 squared is 4 times 2, we get 8 minus 6 plus 1. So when we simplify this, we're going to find that f of 2 is 3. Okay, so now we have to stop and think, is this a factor? Is x minus 2 a factor? And I would have to say no. X minus 2 is not a remainder. That means it did not divide in evenly, and therefore it cannot be a factor of the function. So on the bottom we can see a whole list of when we do long division, what will actually happen. So if x equals k, its solution could be a root. Maybe k is a 0 of the function. Maybe it gives us an intercept, or maybe it's a factor. All different ways. If one of these is true, they're all true. Okay, if one is true, they're all true. This is a different way to represent all of this information. So I could say x minus k is a factor. I could say that k value is an intercept. It's a 0. But if it's not a factor, well, then it's not an x-intercept, or it's not a 0. Hope this helped. Don't forget to like and subscribe.